Okay, so this video is going to go through Dijkstra's algorithm, which is just a way of systematically going through all of the possible routes to find the shortest path. So you could think of this diagram as, town A, town B, town C, town E, town D, town F, and then the numbers could be the distance between towns, and you want to find the shortest distance between the two, between A and F, say. So that's what we're going to do. We're going to try and find the shortest distance between A and F. And you might be able to see just by looking at the diagram that it's going to be 7. But there's a way that we can do it, and it's called Dijkstra's algorithm, and it's just a process. So the first thing we do is we assign 0 to our starting vertex. So if I'm at A, I haven't moved anywhere, I'm 0 kilometers, and we draw a circle around it. Okay, then we assign values of connected vertices. So A is connected to B, so give it a value of 2. So A to B is 2 kilometers. A to C is 6 kilometers, so give it a 6. Alright, so they're the connected vertices. Now what do? Find the vertex with the lowest assigned value on our diagram and draw a circle around it. So 2 is smaller than 6, so draw a circle around it. Next step is look at the connected vertices of your circled vertex and add the edge value to look at the connected vertices of your circled value, add the edge value to the circled value. If the connected vertex already has a value, Alright, so I think that needs a bit more rewording. But basically, okay, A to B is 2 kilometers, but I could also get from B to C in 4 kilometers. So which one's shorter? Well, it's the 4 kilometers one, isn't it? So in this case, the 2 plus the 2, or the circled thing plus the edge, is smaller than the vertex value at 6, so I have to replace it. So I can get to C in 4 kilometers, right? Then I look at the other connected vertices. So D is connected to B, so I can go from A to B to D in 5. Okay, so 2 plus 3 is 5. And I can go from B to E in 4. Okay. Now the next one is I've looked at all the connecting vertices and I've done what I've needed to do. Next step is to, from the uncircled stuff, circle the smallest thing on my diagram. And in this case, it doesn't matter if I have 2 of the same, I just pick one. Okay, so say I pick E, then I continue my process of adding edges to connected vertices. So E to F would be 7, E to D I can get from A to B to E to D in 6, but that's a longer distance than my 5 kilometers already. Okay, there's already a path that I can get to D with 5 kilometers, so I leave that one as 5. Okay, and now again I go and look at my diagram and I circle the smallest vertex. So this one has a weight of 4 kilometers, so I circle that one and I look at the connected vertices. I'm not going to go backwards now, going forwards. So C to D I can get to in 5, which would be the same. Alright, so that's it. Circle that one. I can go from D to F. 5 plus 5 is 10, which is again bigger than my 7 kilometer path. So let's just try and see where that 10 comes from. So I can get from, what was it, A to B, B to D in 5 kilometers, and then I can go from D to F in another 5, so that would give me 10 kilometers. But I'm after the shortest path. Okay, so the shortest path is 7. Circle it. Okay. Now to find the sequence of the shortest path, what you have to do is backtrack through the vertices. So you start at your end vertex and you move backwards such that the end vertex value minus the edge gives you the value at the other vertex. So what does that mean? Well, 7 minus 3 gives me 4, so I've gone from there to there. 7 minus 5 does not give me 5, so I haven't gone that way. Okay, 4 minus 2 gives me 2, so I've gone there to there. 4 minus 2 here does not go to 5, so that's the way we backtrack. 2 minus 2 goes to 0. So in the end, I see that the shortest route between A and F is A to B to E to F. Okay, and it's going to be a total distance of 7 kilometers. So what this algorithm does is it systematically goes through possible paths, and you always just pick the shortest route. And that's what's happening when you're circling the smallest value, and you systematically go through each vertex to check all the paths, and then you just backtrack at the end. So that's the first video on that.